This video is about special segments and lines of a circle. So first let's talk about some vocabulary of a circle. So a circle is the set of all points that's equidistant away from a center. So the interior of the circle then is going to be inside that solid line. It's all points that are inside the circle. And the exterior is going to be all points that are outside of the circle. So the circle is only going to be the line that's making it with all the points. So in this case, what's highlighted in yellow. So let's look at some more vocab of a circle. So the first is a chord. A chord is a segment whose endpoints lie in the circle. So anywhere where you have two endpoints on a circle and a line connecting them, this is going to be a chord. A radius is a segment that starts in the center of the circle and whose endpoint lies on the circle. So you're going to always start in the center and then go to the circle. Think about like a spoke on a bicycle wheel. The diameter then goes across the whole circle. So a diameter is a segment who goes through the center and whose endpoints lie on the circle. So if the center is right there, we have this line going through it. This is going to be a diameter. A diameter is a special type of chord because both endpoints are on the circle, but it's also going through the center. A secant is a line that intersects the circle at 2 points. So a secant doesn't have a start and an end point on the circle, it just passes through the circle, so it enters and exits the circle. So we have our secant entering and exiting the circle. It's going to have arrows because it's passing through. So it's different than a chord because a chord stops on the circle. A tangent is a line that hits the circle in only one spot. So basically it's brushing up against our circle and then continuing on. The point where the tangent line intersects the circle then is going to be called our point of tangency. So this right here would be the point of tangency. So let's use these terms to identify some of them. So in number one, we need to identify one diameter. Remember, our diameter goes all the way through the center. So our diameter here is BA. And we're going to use the segment circle, the segment icon, because it has a start and an end point on the circle. Three chords. Remember, chords have two endpoints on the circle, so one of them could be EB. One of them could be AR. And the other chord, remember, is our diameter because a diameter is a special type of chord. So we also have BA. Tangent. A tangent is a line that intersects the circle once. So we have a line over here that's intersecting the circle once. So ZE is going to be our tangent. Radii. So remember, radii go from the center, and then they have a point that's on the circle. So if the center is S, we have a radii going that way and a radii going the other way. So we have SB and SA. Order does not matter for the letters when you're naming any of these segments. And then the last one is one secant. So remember, a secant is a line that passes through the circle twice. So here's one intersection, here's the other, and this line keeps going. So EB would not be a secant because it stops at E and B. AR keeps going, so AR is going to be our secant. So let's try going the other way where it gives us the piece and we have to identify what it is. So RT is a line. And if we look at RT, it's only intersecting the circle once. So this has to be our tangent, which is J. H is a point. It's in the center of the circle. So this is going to be our center, A. R is another point, and it's where the line is touching the circle once. So this is our point of tangency, F. EA. Now notice EA has a segment, so it's talking about starting at A, ending at E. So this would be a chord because it starts and stops on the circle. AH starts at the center and goes to the circle, so this would be our radius. H, we already said, was our center again. EA EA this time has arrows, so it's talking about the line going forever in both directions. So this would be our secant because it touches the circle twice. And RE goes through the center of the circle, so this is going to be our diameter C. We also have tangent lines. So tangent lines can go from a circle or they can go from multiple circles. So a common tangent is a line that's tangent to two circles. And these are just vocab words you need to know so if you see them somewhere. So the first one is a common exterior, which means that the tangent line is touching both circles, but it's not passing through the middle of the circles. Whereas a common interior has the line passing through the inner part between the circles. Couple more vocab things. Two circles are congruent if and only if they have congruent radii. So if their radius is the same length, so 5 and 5, these circles have to be congruent. Concentric circles are coplanar with the same center. So they're going to be different sizes, but they all have the same circle center in common for the circles. So think about like a bullseye with a target. So we have our center and then all the circles get bigger as they move out, but they all start at that same center point. We also have tangent circles. So remember, tangent is usually a line that touches a circle in one place. So a tangent circle means that the circles are intersecting in one place. So we have inside circles, one circle inside the other touching in one part, and we have other ones where one circle's outside, one circle's inside, and they're touching up against each other only at that one point. So they would be tangent circles. Now the last part is solving for k. So all of these are radii. Remember that in a circle, your radii are congruent. So all radii, anything that's drawn from the center to the edge of the circle has to be congruent in a circle. So in this case, if one radius is 31, x also has to be 31. In number 4, one of the radii is 40, so the other radius has to be congruent, which is also 40. So we can set those equal to solve for x. So we're going to add 2 to both sides and divide, so x is 6. Number 5, our radii are congruent, so we have x squared minus 15 equals 2x. Because there's an x squared, this is a factoring problem, so we're going to move 2x to both sides by subtracting, so 2x squared minus 2x minus 15 equals 0. We need two numbers that multiply to 15 and add to 2, so we have x minus 5 and x plus 3. When we solve, we get x is 5 and x is negative 3. Number 6, two circles are concentric. So remember that concentric means they have the same center. So we have a smaller circle and we have a bigger circle. The radius of the smaller circle is 9. So from here to here, the radius is 9. The distance between the smaller and the larger circle is 4. Well, if the distance is 4, it's going to be 4 anywhere. So if I want to find the radius, I know that the radius of the small circle is 4. The distance between the two the radius of the small circle is 9. The distance is 4. So when I add those together, I get that the radius of the larger circle is 13 inches.